So can we wait for 2 more minutes?
I think
Yes,
let's
better.
let people join.
Sorry, sir.
Yeah, I think let people join. 1 or 2 minutes will should give.
Yeah.
Hello, Lakshmi, you can start.
Yes, sir. Good morning, everyone. This webinar is an initiative of NFE, National Federation of Engineers for Electrical Safety. NFE's vision and mission is to make every electrical installation free from accidents such as electrocution, fire due to short circuit, and increase reliability of it. NFA's mission is to achieve our vision through getting accredited for product and personal certification, which shall focus on electrical safety by design, manufacturing, installation, and maintenance of electrical product, and installation by competent and qualified manpower using quality resources, including product, processes, and procedures. Please visit the website www.nfes.org to become a member of NFE. The last webinar was about electrical safety in hospitals, enhancing safety in Group 2 medical locations with medical systems. Today's webinar is about power quality measurement, IEC TS 63191 2023. And the speaker for the day is Mr. Bala, and the moderator is Mr. Sachin Shelar. The speaker, Mr. Sachin Shelar, is an assistant professor and the head of Power Quality Cell at AISSMS, Institute of Information Technology, Pune. With over 23 years of teaching experience and 3 years in industry, he specializes in reactive power management, power quality, and energy conservation. He has published 27 papers authored 3 books, and has conducted over 250 audits. He established DM Tagar Power Quality Experience Center and held leadership roles in the IEEE Pune section. In 2013, he received a grant from the British and Indian governments to study the UK education system. Professor Shelar is a gold medalist in the bachelor's and master's degrees and is currently pursuing his PhD in power quality. And the speaker for the day is Mr. Bala, energy management expert. Bala Subramanian is a passionate energy expert with experience of over 30 plus years in India and the Middle East. He has relentlessly served customers in the region by providing technical consultancy beyond the business development profile. He handled, having worked with many European energy management and power quality measurement companies. He is continuing his support to provide customers in India. He believes only continuous knowledge sharing can provide perennial improvement and increase energy efficiency among customers. Haribala is thorough in his energy management solutions that blend the appropriate device for monitoring, communication possibilities, and software with result-oriented analytics. He is very much interested in energy management, power quality, and residual current monitoring, which encapsulates the full cycle of energy management activities. With this, I would like to call Mr. Professor Sachin Shelar.
Thank you, madam. Thank you for the introduction. Good morning to everyone. I'm today really happy to honor and feel honored to have this session moderated. The topic is power quality, which is very important, and as everyone is aware, in fact, I will, it would not be wrong if I say that anyone who is attending today's session must be experiencing some power quality problem in his or her industry. So power quality has become very important. But as per the theory, if you see, the power quality measurement and monitoring is done either for characterizing system performance, that is benchmarking, or to characterize specific problems, or for predictive just maintenance. But if I go through the industry, and I have seen that people don't do anything only when there is a problem they are doing it. But now power quality is becoming so important due to automation and electronics. I think it is important to have a specific plan, some guidelines, and that's where the standards comes, the IEC standard, and today's topic is going to be on to that, where we are going to get a detailed plan how power quality measurement should be done, what are the things to be characterized, and how records are to be kept. So I'm sure this would be a very interesting webinar, and we have a very interesting speaker who has a lot of experience from, and he has traveled through the various parts of the world. So we can also get that experience, because from Indian point of view, we are very much novice in power quality. We are yet to pick up it. We have just come to digital meters. We have to go to power quality meters, and then power quality measurement, and then monitoring, and then everything will happen. So with this short introduction, I would like to invite Bala sir, today's speaker, to deliver the session. Thank you, sir.
Thank you, Sachin. Thank you, Lakshmi, for introduction. I'm just sharing my screen right away. Yeah. Very good morning to everyone. Hope my audio is clear to all. If I need to reduce my speed of talking, just give me a say hi and reduce the speed, then I can probably do that. Invariably, sometimes this happens in webinar, and that's why I'm saying this. Today's topic is IEC TS 63191, demand side power quality management. So we all know power quality. We, in a sense, try to do some kind of power quality management, and we wanted to do it in demand side, but without may or may not be knowing that we are doing it in the demand side. So demand side is basically referring to industries here. I changed this topic slightly different to something called as taming an elephant. So I see power quality as a subject is something like an elephant. So everyone knows half of it, but how do we know to put everything together to form a big elephant? Yeah. So this is the topic. Having said this, in fact, I should also, thank NFE for all its efforts for the keep creating a very, very deep understanding and awareness about the safety and security of the electrical system. And in that, power quality is also forming one part of it. I'm very glad for it. So when we have an elephant nicely in a temple or attended by Mahout very nicely, we all like to see the elephant. We all like to go and close to it and see it. It is very nice. But imagine if the Mahout is not giving food to the elephant, and then what it does, it will just go and start having a field day rather than going and spoiling the fields nearby, or maybe the Mahout's own field. It goes and destroys. Power quality is also like an elephant which needs to be tamed. As long as you take care of it, it is very simple, nice, but when it gets out of control, it plays a havoc on the system. So this example, I would start going into the subject, power quality. What is the cost of the power quality in India? So let's just do a small brainstorming. It is estimated around 4% of annual turnover of businesses or industries is lost in power quality. In other words, in Europe and in US, around 120 to 150 billion euro in euro and 129 billion US dollars is estimated to be the loss. And 80% of the PQ issues generated within the industry. These are some of the points which we need to note when we are understanding the whole stuff. This is the research done by EPRI. But in India, how do we estimate power quality? Because unless a problem is reported, then we can estimate. If the problem is not reported, we cannot estimate. So it's very similar to safety. Yeah, you need to have near miss or an incident. So then you start reporting it. Here, many times we do not know that issue is because of power quality problem. So the power quality problem can create different types of losses: production loss, production output, and production output reduces, and then the credibility of deliveries reduces for the company, and there would be continuous failures which are being done, equipment and component failures. But we just go, electrician goes, changes the fuse, electrician goes, changes the component. So they call it as an operational maintenance or operational maintenance cost, which is normal, but maybe that is due to a power quality problem. And that is why I always say industries in this part of the world do not like to have a heart attack, but they can live with cancer. And power quality is something like a cancer. So this is very, very important subject that industries should take care or should start taking actions or start giving attention to it in much more detail. Why? Because in the previous grids, we had generation, transmission, distribution, and consumption straight in a line, step by step. In IT terms, we call it as a waterfall method. When generation happens, it comes to transmission, and when transmission happens, it goes to distribution, and distribution gives it to the consumers, and consumers happily consume the power. All these things happen at the same time, or in real time, but there is a continuous flow which is centralized and unidirectional. But the current systems nowadays are not that way. It has many generating stations, transmission systems are complex. Generating stations are available from a very high voltage to a complete low voltage systems, and it is all inserted everywhere in the network. And then the transmission system is doing a long distance transmission lines crisscrossing all over the country. And then we also have these consumers consuming it at various places, plus they are also injecting into the grid from with the help of microgrids and various other things. Plus they also complicate it more by using high efficiency systems, which can potentially create a lot of power quality issues. Yeah, so this is the whole lot of the way in which the grid is there. Someone has raised a hand. Is there anything to raise their hands? Is there anything to say something? Or please put it in chat. Maybe we can do it in the end for the sake of time. Otherwise, we might potentially deviate from the topics as well. So, but I will be able to get these things through. Then, in the complex world of electricity from generation to consumption, there are so many issues. We have fluctuating power in feeds, change in energy flow direction, sources of disturbances measured at PCC, because that is where we are measuring it. And then we come to some kind of conclusion, who is the culprit of throwing a lot of harmonics into the system. Decrease in short circuit capacity of the power system. This is very, very important, because as the system goes dynamic, the short circuit capacity of the power system changes dynamically all through the network. So maybe at the customer's input, or at the utilities input, or at the transmissions side, the short circuit capacities can potentially vary because of the varying kind of energy, different direction of energy flow and stuff like that. So unpredictable fluctuation power field is one of the consequences of renewable power sources. So especially at wind parks and also at the PV installation, the power can fluctuate. Say, for example, in a place where they have connected, say, roughly around 100 megawatt of power, 100 megawatt of power in a particular area through windmills. What happens when the wind stops? The whole 100 megawatt power becomes deficit in no time. And how do you predict the wind? It becomes difficult. So we can only pray. And when at the level of same levels at the installations of PV installations, it becomes very important where the PV gets connected with the system. So if you connect it in the wrong end, then you have more complications of handling the power factor, or you have complexities handling the various other aspects of the system. Voltage deviations occur very frequently because not all the sources are active always. Sometimes they are switching on and switching off, and the flow of direction also changes in the system. So these are some of the common consequences of the newer grid. And this is what is taken. But what we are doing currently right now is we have standards for transmission system to generating stations on power quality. Transmission systems have power quality standards. Distribution has power quality standards, and consumers also have power quality standards. So most of the time, these are applied at the point of common coupling for various people. So from generator, where it is giving it output to the transmission system, for transmission systems and the utility, it is at the point of common coupling at the grid stations, where the power is getting transferred into the utilities, and then from utilities to consumer, where the power is getting transferred from the utility into the consumers, which we call it as a point of common coupling. And what do we measure at the point of common coupling? Most of the time, we do this, and we do the limits. Yeah, limits are the one you say that don't pollute my system beyond this value. This is what they say. Say, for example, In the consumer side, we will say, utility will come and say, don't pollute my system beyond 5% of harmonics. Don't throw more harmonics into my system. Your limit is 5%. You can throw, but it is limited to 5%. So there is a limit which is set. So we only try to follow the limits rather than trying to understand what inside is happening inside our system, inside our load sites, for example. So this is much more difficult. So it becomes very difficult for us because we are only focusing on one place. Yes, we have to focus on PCC, but if you have to control that PCC, you need to do much more activities on the load side itself. So that is very important in this part. So what all the standards we have in the relevance for the relevance in the network? You have 61000-2-12-2-2 for transmission, 5160 and IS17036 for distribution systems, and IEEE 519 for the consumers, where it clearly says voltage is the responsibility of the distribution companies and current harmonics is the responsibility of the consumers. But all these things give limits for harmonics, individual harmonics, TDD, THD, everything is specified, and we have to work within the thresholds what is given in the standards. So in demand side power quality management, which we have right now called as IEC TS 63191. 63191 is basically TS. It's basically a technical standard which will be emerging into a standard soon. Yeah. So we are all lucky to have this information much before so that we can start thinking about it and start working on this. This document provides guidance on how to establish, implement, and maintain demand side power quality monitoring system. So we are going from power quality management to power quality monitoring system. So what is that monitoring system? Monitoring system is basically you measure, understand what it is, and then take a decision. But in this particular standard, it clearly gives us a guidance. How do we measure? What we need to consider for measuring the power quality in the system, in the network or in the consumer's place. So demand side refers to the load side or the industry within an area. Nowadays, it becomes very, very important that industries of a data center, which is a small 5-story building, can consume just like a power, like a big furnace, which is melting iron and steel and stuff like that. So a small area can be more power intensive. So that becomes, which means they are also potential to throw a lot of harmonics by usage or in their loads inside their systems. Yeah. So the scope of the power quality measurement system here is defined here as objectives and constraints, assessment of initial power quality measurement situation, definition of an action plan. So we need to be defining an action plan to improve the power quality measurement system. And then the power quality measuring system is implemented. So wherever there is no devices or measurement system, implementing these devices, installing these devices, in other words, and then taking the data from these devices for the improvement of the power quality situation. Unless otherwise we have the data, it is very difficult to manage the power quality system. So that is why many of the energy auditors try to compensate that by having an instrument themselves, because the customers don't have it or they don't want to have it. So this always happens. That also gives a good business opportunity for the auditors to have an instrument and then do it. But whether that is that be sufficient for the customer to resolve the problems of power quality is a question mark what we have right now today. Yeah. And of course, once you have a good measurement system, we need to maintain it and maintain it as well. In this particular 63191, they have given 6-phase measurement plan. So the measurement plan is for 6 phases. And at the end of 6 phases, we are all going to judge, or we are going to provide scores to the industries that how much their ability to do the power quality monitoring. Once the monitoring becomes perfect, then you also have a set of good application which can come into it. Thereby the solution for power quality mitigation can happen effortlessly. This is the idea, because everywhere there are standards, these kind of problems, these kind of effects, these are the mitigation possibilities. So we know all these things, but we need to measure and see whether you need to take action, and if that action is taken, up to what level, with what kind of mitigation equipment, becomes much more easy. So let me tell you, the standard stops at assessing the ability of the demand side power quality measurement. Yeah, so this is what it is. So that is why it says it gives a levels of DSPQ, that is demand side power quality, as rank 0, 1, 2, 3, which rank 3 is good when you score good marks. In fact, when I was going through the study of this particular standard, I was feeling very elated, because I'm going to judge someone. We like judging some people, judging some actions, judging how the flight, if you go on flight, I have a habit of, if I go on flight, I have a habit of looking at what is the kind of, I give marks to various activities and try to find out what is the kind of service I have got on that particular date for my own actions, for a simple terms. So, but this has come into standard for the power quality level here. So this is what we are exactly doing over here, ranking it 0 to 1, 1 to 2, 2 to 3. And if we are able to get up to 3, then we are ready for our mitigation aspects itself in a much more higher level. Yeah. You can do mitigation anything, but if it's like going and checking for HbA1c and immediate instant sugar level of us, right? Both gives some kind of a parameter. But what happens is, there is always a possibility of improvement when I do the study from time to time, so that I get to know what is the benefit, what is the amount of investment I need to do, how much I can work out to get things through. So this character is doing this. I always give this example. I have a diabetes. I go to the doctor. They send me to a laboratory. Then they take an immediate sugar level, glucose level. Then they also take HbA1c. And then they say, okay, this is your sugar level. Now I say, I don't accept the sugar level, because my wife is not giving me proper food. That's not my case. I need to do my workout. Then only I can bring down my sugar level. I can't just cannot blame that my family or at home I'm not getting a proper food. That's just not possible, because there is so many things which needs to be considered from our side, from within the industries, so that these scores can be improved. So these scores will give us a guidance, where do we stand, and then where we can improve. So this is the first level of it. So I'm dividing this whole standard into three parts. The first part is the phases of measurement. The second part is the power quality information, or the power quality parameters, what we need to monitor. And this standard gives an elaborate information on the power quality problems and the effects, how to mitigation possibilities, and also what parameter needs to be measured. So it gives a complete information in the chapter number 5, which is very important for us. So, but it also defines the 6 phases. This is the first part. Second part is the power quality parameters. And third part, what we will be seeing is how do we evaluate and put points and judge it. Give a judgment on whether how we can improve it. So that's where we are going to. These are the 3 parts. So I would require your attention for the next 30 minutes or so that I will try to compress it and try to give it everything, because this document was almost 120 pages. So I'm trying to put everything together in a gist to make it easy for us to understand and start taking actions on this. So the 6 phases of measurement plan, this is the first part. It says the phase 1 to phase 6. Phase 1 defines the context and objectives. Phase 2 defines the initial situation of PQ measurement in the industry. Phase 3 defines the design and action plan to improve the measurement system. Phase 4 defines implementing the action plan to improve the measurement system. Phase 5, the users using of the measurements data. And 6 is to maintain the measurement system. So there are 6 phases identified. We may be doing many of these phases here and there, now and there, in many places as per our requirement. Or if some incident happened, a big tripping happened, then we do this, and then we do some reporting, finish it off, and then go start doing the next work. So this always happens in most of the industries. So let me go into the first phase of value. The first phase also, every phase you have the goals, you have the motivations, you have the stakeholders of the organization, including your higher managements, and budgets needs to be allocated for the whole process, all the 6 phases, in fact. And then the planning, how do we do it? How do you plan it? Who will install it? Whether I can install it or I can put someone, contractor, to install it, or we will have the, do we have the resources to do the installations and maintenance, collecting data? All those things needs to be done. So the level of measurement is one of the criteria. What it gives here is ability to quantify the power quality by site, by zone, by source, and relevant loads. So we will have to understand or analyze or demarcate our industry as zones by application or by relevant loads to understand, to quantify how much where we need to do power quality monitoring. The second part is the ability to take the readings from the quality points at the regular interval. So we need to be understanding how do we take the readings for better power quality measurement monitoring purposes. And then what are the influencing factors that affects this? So what all the influencing factor affect our power quality within our organization? Maybe it is some kind of a specific loads, or it is some kind of a customer who is a big customer who is adjacent to me is throwing a lot of harmonics. That is also an influencing factor. And then we have to see the monitor, how do we monitor the existing installation power quality, and how do we analyze the power quality situation in our system. These are the major criteria which needs to be defined and factored in the first phase. And then we give the summary of the deliverables. This is more of a planning activity where we say, okay, my last time my DSPQ ranking was this much, and I wanted to go for DSPQ ranking from 1 to 2, and then if I have to go to 1 to 2, what all I can do it. That is the ability on the 5 points which we discussed, put forth will come into the picture, and then we do it. This is phase 1. When it comes to phase 2, we divide the zones. I was telling you, we actually try to create the assess the situation by creating into zones. Say, for example, a zone is a building within the factory area, can be. A zone is a production line, a complete production line. A zone can be, you can create as many as zones in your factory. It is a virtual one, right? So you create, this is the production line for tires, this is the production line for, say, maybe some other rubber products, this is the production line for painting area. So these are all called, these can be created as a zones. And then in these zones, we should have devices. So it also tells what kind of devices you can have. So this standard classifies as 2 major devices called as PQI, power quality devices, and PMI, power monitoring devices. Yeah. So these are all as per the standards. There are as per the standards, these devices are then 62586 for PQI, and PQI is further defined in a much more better standards. The latest one called as 61000-4-30 as Class A and Class S devices. And then the standards say 61557 for the PMI devices. So now, why should I use two different devices? Because I get one MFM multifunction meter in the market for say 6,000 rupees. Why should I install two different types? It becomes easy if I have to maintain my stocks in with one devices if something has to replace. That's not the idea. I put that question differently. We don't use the same switchgear, same trip units all through the circuit from incomer to the outgoing. We use it accordingly because there we say protection. Because of protection, because of discrimination, we wanted to have different kinds of system, different kinds of trip units, different kinds of tripping system, different kinds of braking systems, so that we have an idea. We don't use the same MCCB all over from the incomer to outgoing, right? So we always say, no, that is as per the current we do it. So the same way, according to the information what we want, we also have to be using the PQI devices and PMI devices appropriately. Yeah. It also further down, we also classify this PQI devices into two and PMI devices into two, which we will be seeing it as well. And then we need to start seeing how we are able to taking the data reading and storage into the system. This is the phase 2. Yeah. In phase 3, in phase 2 also, the zone, which if I have to elaborate it, probably this is how I elaborate. In a site or a plant or a facility, a zone is a physical area. Under that zone, you have use area or an application area, which can be a simple production line or something else, which we should be able to monitor. So we are dividing a site into zones and uses or applications. So in a painting line number 1 or painting line, certain missions can be classified as uses as well. Or certain painting missions can be, or dryer unit, or the painting unit can be used as an application as uses itself. So I'm just giving an example, but industry is the better people to analyze what kind of zones and what kind of users they have, because we will be judged by the zones and users also. The farther you go drill down, you have a better idea of scoring higher marks. Yeah, that's how it is. So you have zone 1, zones, you have users and site in the zone classification, which we need to be understanding. So the same way for the power metering and monitoring device and power quality device, PMD and PQI. So this can be a combination of one or more devices of several functional modules. We call it a simple multifunction meter, but no one says what functions it does. We only say it is a multifunction meter. No one have defined clearly what the functional modules are. So this is a very important thing. So we need to know what kind of measurement is that particular meter is doing. The same way for PQI also, what kind of functionality, whether it can be classed as Class A, which is a legally acceptable class function, or a Class S is a statistical evaluation function of measuring power quality parameters. So we need to do this. So what happens here? They have divided this into PMD2, PMD3, PQIS, and PQIA. So this is a very important table where it says what these meters should be measuring at least, so that to be called as PMD2, PMD3, PQIS, and PQIA. So it is a very important table again, which gives us each meter has to be different to be going into where the users are, the zones are, and the major sites are. Site is predominantly a factory, and their incoming is called as a site, which is defined over here. So these are the 6 phases. In the second phase, we have the zones and users classification. On the devices, we have the PMD devices and PQI devices, and each device, what it can measure, comes in this particular standard. Now the defining the goal of phase 3. actions to undertake, improve and achieve the organization. So now we know, understand the second phase, we know what all the points we have. That is in the assessment also, we have certain number of devices, give specific points for us so that we can accordingly mark them for this particular phase. So what is the proposal for improvement action? So probably what we can do is we can target the zones, and this zone I wanted to start with. This zone I wanted to fix certain kind of meters in PQI meters in this zones. These loads, these application loads require more because I have more number of variable frequency drives in this particular application or uses. I will have better meter in these places rather than a PMD products. I will have PQI. So we have to choose accordingly at various zones and in applications, and then try to improve the monitoring system from level A to level B or level 0 to level 1. So this is very important in doing this. And once we do this, we prioritize the installation of the devices in various places so that we first improve the monitoring perspective of this particular whole system as well. Yeah. So that then we do the review. The fourth action is the installation action. We need to ensure the implementation of this particular process. That is, wherever we want, how do we put the meters, which device we need to put, and all those stuff. We need to start the implementation action, like whether do we have proper CTs, whether the CTs are properly configured and has the relatively reasonable accuracy, which we can use it, or we have to buy a new CT, or we cannot install a CT in that particular place because the panel is having a smaller area. So probably we can use alternative methodologies. We need to be having a look at it in this particular phase. And then the installation and commissioning of the measurement devices starts. So ultimately, by following whoever you are buying these devices from, follow the manufacturer guidelines clearly and the manuals. Generally, many customers do not read manuals. They think that if I know S1 and S2, I can connect the CTs S1 and S2. If I have V1, V2, V3, I will connect the voltages and it is done. But it is always better to understand the manual, which becomes helpful in doing this. So this is one of the criteria in this particular phase, to reading the manuals itself, So we need to be doing that to understand the product perfectly so that we can take as much as benefit out from this product. So that is what is very important. Nowadays, the electronics has improved pretty well, that we can do much more than what we are currently doing in these devices. One of our devices can give an output if there is a voltage low. So a demand control activity. All these things can also be done with these kind of devices. So we need to be understanding these perspective as well in making sure that doing it. MFM means is not only measuring voltage, current, kilowatt, kVA, kVAR, power factor, frequency. It is much more, and that is what we are trying to learn today. Yeah, this is on phase 4. Phase 5 is basically about storage of power quality data, whether you are storing the data in an automatic way or in a manual way, or you have a mix of automatic and manual way from these devices, and then collecting the data into the system. So analysis then comes once you store the data, then you start analyzing the power quality data itself. So it can be done either with an internal expert or an external expert. Having said this, the phase 1 in the stakeholders, we need to be very, very clear that we need to have someone responsible for the power quality within the plant. So a power quality manager is very much required, so that he leads and he becomes accountable for the power quality measurement actions. And then he can do the analysis with a third party or an external experts as well, but it is very important someone leads within the industry the whole power quality as a subject. So this is one of the criteria in phase 1, which we will do. We will also see it in the later part of the slides. Decimation and protection of power quality data. How do we share the data? It becomes very important. This is another industry's vital problem. The maintenance department doesn't want to give certain information to account department, and account department doesn't want some information to be given to maintenance department, and energy manager who is sitting on top of the maintenance department, who is in charge of managing the energy better, he doesn't have communication with accounts and he doesn't have communication with the maintenance department. So there is a mix of silos, who are siloed types of people who are working. Then ultimately no one gets the transparency of the data. So the data needs to be relentlessly shared the same way across the industry stakeholders so that they get their benefit out of that. Electricity is not only a problem of the maintenance department, it is the problem of the whole company. If it doesn't managed well, then the whole industry is going to suffer. So that is why transparency of data, power quality analysis, and storage is stressed in phase 5 of this. Phase 6 is much more simple. Once you establish the system, then it starts running. You do the firmware updates of the software, because many of the devices nowadays, electronic devices, has the possibility to upgrade by just changing the software inside it. So if a product is able to upgrade the firmware, we do upgrades of Microsoft, we do upgrades of our various other applications. Why not for the meters as well? So firmware updates for these devices should be easily available, and it should be done at site predominantly. So these are some of the phase 6 measurement and maintenance systems, how we do it. So there are 6 phases. We have gone through the 6 phases, and now this is the first part is concluding with this. I will go to the second part and then come back to the third part to relate this with the first part again. So the third part and first part of this particular webinar is more important. So I would like you to stay tuned, because the second topic, what we are going to talk next, is all about power quality disturbances and their impact in the system. So we are going to talk about various power quality disturbances and their impact on the system. One impact is very common to all. Whatever is the power quality, that is the financial loss. Interruption of process creates financial loss. Equipment damage and aging can also causes financial loss. Production loss causes financial loss. Waste of raw material, again a financial loss. Loss of data in a server, again could be potentially a financial loss. Increased losses in electrical equipment and distribution system. So energy can be wasted. So again a financial loss. Disturbance and interference of electronic appliances and communication networks can also lead to financial loss. Malfunctioning of protection relays can also relate to financial loss. So the whole summing up of the power quality disturbance is financial losses. And I hope people agree with this, but many times we don't agree, because we say, I can manage cancer, but not heart attacks. That's the reason. So the next part of it, we classify the power quality as continuous phenomenon, events, and other phenomenons. So we have been discussing this in many forums, the same thing: long-term frequency variations, voltage variations, voltage and current unbalance, flicker, and harmonics come under a continuous phenomenon. Short-term events like voltages like voltage dips and interruptions, supply voltage, sags, swells, transients, rapid voltage changes comes under the category of events, short-term events. And then there is something also called as main signaling, which in India we do not have, as far as I know. because certain utilities use main signaling frequency for changing the tariffs in the energy meters. So unfortunately or unfortunately, we don't have that kind of tariff change. We have only time-based tariff change in most of our utilities. So I'm not going to give importance in our discussions about the main signaling in this particular webinar. Where are the origins of these power problems? So one side I have said short-term events, long-term events, but where are these origins? Can be from supply side or also from the demand side. Supply side can be for frequency variations, voltage variations, voltage harmonic and interharmonics, voltage unbalance. Demand side can be current harmonics, current unbalance, reactive power, neutral current, rapid voltage change. Some of these can be termed as demand side disturbances, which can be common for either from the supply side or demand side, as voltage sag, swells and interruptions, voltage transients, and flicker. So it is very important that we understand where these supply voltage dip, sag, swells, whether it is coming from supply side or demand side, need to be analyzed and understood as well. So these are some of the quicker part which I can tell you. I can hear some of the minds asking, why current harmonics, why voltage harmonic is on the supply side? Because current harmonics can distort from the demand side, can distort the supply side voltage harmonic. So, but that's why we have a demand side current harmonic needs to be measured, and voltage harmonics can also be measured by switching off the supply, switching off the loads, and then doing a short-term supply. So whenever there is a power shutdown in our plants, we should also understand that we should also start measuring the voltage. How good is the voltage quality? If my loads are all shut off, how good I am receiving it. So that will also be a good exercise whenever there is a shutdown of your loads for maintenance purposes. Thereby you can also check the origin of the power quality problems from the supply side as well. So I'm going to go through some of these parameters in a very quick way. I am ready to share this presentation if it is asked for. So we can always share this, because there is nothing, if everything is common, I have just taken it from the standard, whatever is there, and then try to make it as a gist for easy understanding. So the frequency deviation results from the source. So this has lot of effects on the loads. So I'm not going to read through most of these content. I'm also running with the time. So this is very less of an issue currently in India, I suppose. So this is predominantly this frequency deviation can happen when there is a big plant having their own source of power. And these kind of issues can happen where especially when they have multiple sources of power, like PV, cogeneration plants, and also a windmill, some certain kind of loads from the utility side, it can happen. But ultimately, this needs to be taken care. The key parameter to be monitored is frequency. Yeah. So all power sources and their control power system should be assessed for mitigation of this particular frequency deviation. The magnitude of supply, I have just given a graph of if the voltage varies, what all the things can happen in a normal motor. It can vary the torque, it can vary the motor efficiency, it can vary the starting of the motor torque, and it can vary the power factor as well. So it can do multiple, affect the multiple performances of the motors in general. So, but we need to be handling that as well. So as a magnitude of voltage is taken over a period of time. So there are standards for that. So, but this needs to be measured as well. So voltage monitoring becomes very, very important. And we need to know when the voltage is going low, when the voltage is going high, and needs to be recorded appropriately so that we can correlate or how much of time we are in a lower voltage side and how much of time on a higher voltage side. Yeah, so that is happening. Some of the multifunction meters can also provide alarms for the voltage output. When the voltage is high, they can also give some kind of an alarming system so that people know that those alarms can help them be alert of the situation what is coming up for them. Then the flicker is another important factor, which gives the shivering of the sine wave. The sine wave will shiver politely which can create problems for the human eyes under lighting condition. Yeah, under lighting condition. So for normal lights, it can affect the human body. I remember when we were doing, when I started my career, we used to have something called as electroencephalography in biomedical systems, where they put before a patient a light to flicker, and they do the sensing of the brain waves. So that would give them a very big idea. So depending on the frequency of the flicker, the brain reacts differently. Sometimes we may also feel that in certain areas, if we go, that we get we have a discomfort on our feeling of our eyes especially, and then we wanted to come out of the place. So the key parameter measured is PST and PLT for the flicker in these devices. There are mitigation processes possible. So increasing the short circuit level of the system is one, as per the standard. That's what it says. Or it can also say you can also have some VAR compensators and thyristor capacitors, or both, to control the flicker in the system. The third point is the voltage dips, sags, swells, and interruptions. There is a terminology difference. Some call it as sags, some call it as swells. Sag and dips, rather. Sag, and some call it as sags or dips, and some industries still call it as transients, or they call it as voltage jerks. So these are some of the terminology used, but the normal terminology used is voltage sags and swells. Yeah, so this can happen from the transmission network. It can happen in the fault in the installations. When there is a heavy loads which are being switched on and switched off, then voltage sags and swells can appear. Bringing a big capacitor bank inside can also increase the voltage levels, swells for a short period of time. So some of the voltage stabilization systems like UPS or power conditioners can also create voltage dips and sags. So this we need to potentially be aware of. Unscheduled downtime is the effect, because suddenly something happens, the PLC trips. The VFD, sensitive VFDs in pharma companies can suddenly trip, stating that low voltage. But when we go to the multifunction meter, we say it is always 230 volts. We come back and tell them, no, there is no voltage getting low, but it could have happened within 20 milliseconds or 10 milliseconds, which your normal multifunction meter cannot sense. So then we have tripping of contactors. When the power to the coil of the contact is lost for a certain time, then naturally it releases the contact. Then you have stalling of motors, and lighting effects can also cause the voltage sags and swell. Mitigation can be with static UPSs, flywheel arrangements, dynamic voltage restorators, power conditioners, or utility PQ improvement partnership. I marked it in yellow to make it important. None of us today share to the utility that what kind of problems we have. One is we don't have the data, that is different. But even if we have data, we don't share this with utility to say, look, I have experienced these kind of problems, power quality problems. So many times the power quality voltage has dropped. We need to share this with utility. That's when they will also know. If an industry writes to an utility stating that I am getting voltage transients very often, can you please correct it? No one will be able to rectify this problem, or no one will be able to give attention to solve the problem as well. So it becomes very important to give a lot of data to share it with the utility, so that a clear utility consumer partnership can be attained to improve the total power quality of the system, especially the voltage dips and swells, because it can either happen from the supply side or it can happen from the load side. But we need to be understanding it. Whoever is important, whoever is having it should be in a position to correct it and then do it. The major, the important aspect where what we need to collect as a voltage parameter is the voltage events. So in EN 5160, it is classified as to what level the voltage is going low and what time it is, how long it is going low is classified and put it in a matrix. So we understand this matrix and then try to understand how do we do it. There is another new standard called as IEC TS 62749, which is making it more simpler. It puts both sags and swells in one table, which is on the left side of your screen down below. I have made it very smaller table because it is to say that it is an emerging way, but we can give so many number of times my voltage has crossed 80 to 70%, 10 times in a month or in a week. We have to start giving this information when it happened, how long it happened. So 70% it went low, 40% it went low for 10 milliseconds, 20 milliseconds. So the depth and the time needs to be clearly defined and we can create it as a report. And that's what EN 5160 or IS 17036, which does that. This is what is the emerging standard, which I have told you. So it tells you again 10 milliseconds to 60,000 milliseconds, which is 60 seconds. How low the voltage goes needs to be recorded how many times. So if each cell you will get it 3 times it went, 4 times you went. So this forms a good report for anyone to understand how the voltage sags affect the industries. Yeah. So you can compare it with your adjacent companies or industries, so that if they too have the similar kind of stuff, then you both can go probably and talk to the utility also, and they have to take actions. If not now, later also they have to take this action. So but giving the data is very, very important. So the transient over voltages. The transient over voltages, again, it is only happens within a cycle. That is what is transient. So let's not confuse between the sag swells to transients. Transient happens within a cycle, or it can be oscillatory, or it can go very high and come back in microseconds. This can be an effect of lightning, or it can be an effect of switching off in an electrical accident happening somewhere. These things, the transient over voltage could happen. Effect of the transient over voltage is also phenomenally dangerous, because it can spoil or rupture your insulations, or wherever there is a weakening of insulation happening, it can rupture the insulations, and a major breakdown could result in. So the transient over voltage cause up to 30% of the disturbances as per the standard, what we say 63191. It says 30% of disturbances are happening because of transient over voltage, and 70% of them originate from switching of the internal loads. So this is very important thing which we need to understand, that while switching on the internal loads, there can be, because anytime they will, in the industries, they will complain, I switched on this particular load, my system on the other side of the factory got a cable failure or an insulation failure, or some kind of a tripping happened. This can be due to voltage transient also potentially. Yeah. So this can be done by mitigated by using surge protective devices, or by redesigning the right system according to the proper standards. And equipotential bonding, design of earthing also becomes important in this particular case. Then the supply voltage unbalance and current balance. So unbalancing again is because whether the phase angle is of the 3 voltages can change, or the amplitude can change. So then it becomes an voltage or current unbalance. The key parameter measured is voltage unbalance and current unbalance of the system. The summing up of all the 3 voltages can also give you the voltage imbalance. The summing up of all the vectorial sum of all the three currents can also give the current unbalance, or in other words, we can also call it as calculated neutral current. So this is also possible to be measured in these devices, PMD and PQI devices. So these things has to come in. In fact, protection equipment is recommended for motors, for especially for the voltage transients. Protection systems are recommended for motors as per the particular standards. That's what is the commentary says on. Now our favorite topic of harmonics, voltage and current harmonics, FX. Everyone knows about it. Triple N harmonics is also dangerous, and it can potentially create safety issues of burning of neutral conductors. There can be an increased overloading, that's an effect, but it is predominantly created by the harmonic currents, non-linear loads. This can in turn harm the voltage waveform as well. Yeah? A large amount of current harmonic can harm the voltage harmonic. Already harmed voltage waveform can again potentially create more harmonics in the neighbor's system. Yeah, that is also possible. So it is like you throw garbage into my street, into the street, and I take the same garbage and I feel sick afterwards. So that's how the whole process goes on. Yeah. Then we have what all the key parameters we need to do it for the harmonics. THDV depends on the system impedance. THDV can be good or bad, because when most of the supply systems are good in quality with a pure sine wave, and depending on the system impedance and depending on the current harmonics, what is thrown into the system, the voltage THDV takes into effect. Now there is also a TDD, which is measured at the point of common coupling for the consumers. So this point is not added in the system, but I have added it as TDD. That should also be measured at least at the PCC, so that we know where we are standing. Yeah, so it's like this. Then the neutral current measurement, harmonics up to 25th order is recommended. 50th order can be a good practice. So we need to know. Very important thing which I wanted to tell here. If someone says I have THD in my device, the next question we need to ask is, up to how many order of harmonics you consider for calculating THD. So this is very, very important. The device can measure only up to 10th order of harmonics and then still give THD. A device can do it up to 50th order of harmonics, and then still for THD they calculate only for 10th harmonics. There are devices like this. That's why I'm saying. So we need to be having very clear understanding of the device, multifunction meters, or the PQI or PMD devices in this case, to understand how they calculate THD, how they calculate THDI and TDD as well. Yeah. So this is very important in this case. Harmonics mitigation possibilities requires a lot of design knowledge, with which we should be able to do it either with DC, AC chokes. I have a spelling mistake here. And then the harmonic filters, which can be active or passive filter. There is an emerging trend to monitor 2 kilohertz to 150 kilohertz also, but it is still in the books. We should be seeing how this is emerging, because lot of sensitive manufacturers have started giving a good amount of devices or an equipments in the system which controls the lower order harmonics but gives the higher order harmonics very badly. So that is still a problem. So that is why that when the new equipments comes in, we also have to be very clearly aware of the harmonic frequencies beyond 2 kilohertz. Yeah. And another important point is the harmonics can distort very badly the waveforms, as we all know, and multiple zero crossovers. Whenever the waveform crosses zero, because of the distortion, it will do multiple zero crossovers in the waveform, and that can become too much bad for the system, because it can potentially, all our systems are designed for a pure sine wave, and it means 100 crossovers a second. And if we have more than 100 crossover, our electronic equipments, our drives doesn't know where they are, and they will potentially can create a much more problem where what is envisaged. The last point on the power quality disturbance is the rapid voltage changes is another point, but it doesn't have much of a significant, but we need to know how much of voltage going low and then how much it takes to come to the steady state. But the standard tells us, please at least count them. How many number of these kind of actions is happening in your system? So less than 3% RCVCs in a certain voltage, how many times it happens in a month or in a 24-hour period, so that it will help us in analyzing it much more better. Yeah, so this is the way RVC talks about. Now, this table gives us the potential impacts on the assets, potential impact on assets and or the energy usage, how it happens. Say the voltage dips can impact the assets or the equipments. The voltage dips can affect on the energy usage of the equipments, and then the voltage interruptions has the impact on the energy usage. So this table is already given, which is a very handy subject when we have to go and explain to some of the industries, at least. And it also says third harmonics and multiples or triple N harmonics is much more bad for the safety of the industry by itself. So that's a very clear understanding what we have in doing this. This one gives with respect to the uses or the applications. So how it affects voltage dip can affect a motor, lighting, loads, appliances, HVAC and transformers. This is another table which is given over there. Then we come to the last part of our webinar, which is the ranking. How do we rank the whole system? How do we tell that which level whether the industries are in? So we, as I said, DSPQ 0 to 01, and how do we assess it? How do we assess where is the chart for it? The chart goes next line like this. It is like various subjects in our college days with a code given. Yeah, EX01, EX02. It is very similar to our syllabus in our college. For each and every place, we have the marking system. We mark, add up, and then give the values. So I'm going to go through these in a very quick way. I'm exceeding my time, but please excuse, but this is very, very important in the whole webinar, what we have seen right now. So let me go through this. So if we have a dedicated internal PQ manager, then you have 10 points. If you have a dedicated PQ expert, either internal or external, then you have 10 points. So you have to start doing the pointing system. So every time we can increase it so that we will have this particular thing added up into the system. So you have one, it doesn't mean that you have two people of PQ expert, you put 2, so into 20, but you have to make it as 10. If you have one or 2, it doesn't matter. Then you get those 10 points in this place. Yeah. And then the second one is, how do you use the zones and devices? So for example, you have divided your factory into 3 zones like this. And then you say, I am having meter only in 2 zones, or this is being measured in only in 2 zones. Then ratio becomes 66%. So if I'm above 50%, the point in the table says 2. Otherwise, if it is less than 50% of the zones covered, then it says a point, now 0.1 point should be added into the system. Yeah, so this is how it talks about. And then you have for the zones to users. Yeah, I have come into the users. Yeah, how many users you have the meter, or how many sub zones, rather you can also term it as a sub zone. The use is a bit of a cringy terminology used in the standard, but we can also say sub zones. So I have sub zones within zone 1. I have sub zone use 1 and use 2, which is here, and what kind of meters we put in over here. Depending on the ratio of the meter, you again have the marking system or the points table which we put in over here. Say for example, in this case, you have 2 meters in 2 uses, but you have 6 uses or 6 subzones, then I cover only 33% of the place. Then I put a marking of 2 points for this particular category. Then you have PQ marking granularity level. So which means it is a mix of all the places. What kind of, how many meters or meters you have put. So you have one monitoring for all zones, one monitoring per significant zone. Significant zone is partial zone. Yeah, significant means in this case, it is partial. So I cover only 2 zones here with these devices, say probably one here and the zone 1 and zone 2. Zone 3, I don't have a device. So it is a significant zone or a partial zone. Out of 3, I cover 2. So out of this, again, you say, if I'm covering it for at the mains incomer, then I have 1 point, 10 point, rather 1 point. One monitoring of all zone is 1 point. One monitoring in partial zones is 2. One monitoring per zone is 4. One monitoring per significant use is 6. So as long as you have more meters downstream, your points get added up here. So this is a very important aspect, and the scoring will tell us that we have devices and these are all marked with correct points for us to assess the end result. So how do we do this? The same kind of devices, PMD2, PMD3 is already, which we have discussed, is coming up over here as well. So in these cases, we say, this is the 4th monitoring, PQ monitoring granularity level. I use PQIS, PMD2, different devices at different levels. And accordingly, if I am using in my whole system PQA, I have 8 points. If I am using PMD3 kind of devices, then I have 2 points. And then if it is not with respect to the number of devices, it is with respect to whether you are using these kind of devices in your system, which means, takes us to a place that we should use different kinds of meters or devices at different levels. Thereby we gain more points in this particular way. Yeah. And then you have the ability to quantify the influencing factor. So what kind of parameter we measure, and or what kind of equipment we have for mitigation equipment. So this is the second part of it. So we can also have, if I have a PFC, I have 1 point. If I have a harmonic filter, I have 2. If I have a static compensator and harmonic filter, then I will have 2. So you have these kind of monitoring, which we monitor and add it up into the system. It also takes care of the what kind of potential equipments which can create harmonics. So we have soft starters, like which is called as motor starters here, IT equipments. These are all can pull down your marking system. So, but you need to have them in your system to get this. So we need to have, if I have 10 motor starters, I have 1 point minus. IT equipment, 1 point minus. If I have welding systems, then I will have 1 point missing. Otherwise, there is no required to reduce the points. So you have to add up these points and put it as well. And we should also talk about the neighborhood, how they are. So if they are having a disruptive neighborhood, I have 1 negative point, and bad quality of power, I have bad quality of power delivered by the utilities, then also I will have 1 negative point. So these points gets added up in the final phase. So I will give you that example. And then how do we collect the data, whether we collect it on a manual basis or an automated basis, whether we collect it on a daily, weekly, monthly basis, we have points which gets added into the table. And then you have short-term and event monitoring ability. So when your monitoring ability is, you can monitor voltage dips, yes. Then you can have 4 points. If not transients only, then it is 2 points. So this table can be followed. But it's very important. It says if the event is monitored but not analyzed, then the number of points is 0, which means I have a meter, but I don't see the data from the meter. I don't analyze it. Then the point becomes 0. So as an energy auditor, we can always go and ask, are you analyzing it? Can you show me certain analysis? Then if that is the case, at least they can write a comment that this problem is because of this issue, or I don't know about it, something like that, so that they know that some analysis steps are taken and then we can give points based on this point. And then you have the ability to monitor and analyze the current phenomenon or a continuous phenomenon. So if you are able to analyze THD as a current, then you have certain points. If your THD is measured in these devices, if your power factor is measured, you have certain points in this case. So you have a complete information. And then frequency verification also comes onto the same thing. Frequency of verification for this there is there, and then how soon the data is managed, how long you have the data backup in your system, say 2 years, 3 years. That will also give you a fair amount of information. So ultimately you come up with points for all these table, and then we come up with an answer, total all the points, and say if my DSPQ 0 is 0 to 10 or 11 to 30 or 31 to 70 as DSPQ 2 and DSPQ 3. There is nothing wrong if someone is low, but we can always improve on it. So improvement also we have told, how do we go about it in the 6 phases. So this will give us a complete information of how things work on the DSPQ level. So the best PAQ monitoring system is as good as the interest taken by the industry. The best PQ device is as good as the data used and analyzed by the industry. So whether you make or break, it is the industry who is going to get benefited or not getting the benefit out of it. Thank you very much. I think, Sachin, I have overrun a slightly few minutes, but I think it was it is okay for this at this point of time. And thank you all. I'm ready for Q&A session if there are any questions.
Yeah, sure, sir. Thank you. I can understand it's not easy to teach standard in a very short duration, but I must appreciate you have done a wonderful job. You know, initially anyone, if you go on reading standard, it's difficult to understand, but you have lucidly put it very well. Clearly, you have introduced to 63191, which is a technical specification, soon going to be standard. And you also interestingly, we gave us DSPQ score, we'll remember it. Also, people got to know PQI and PMD, that is insights for selection. Multifunction, you told a very important point. People should read manuals of multifunction meter or any meter. So that is to be taken seriously. PQ manager concept I liked. Just like there is a energy manager, there is a must requirement for PQ manager. And PQ disturbance you have reviewed. So thank you, sir. There are few questions in the question and answer. Should we take it one by one? Are you able to see question answer section?
I have to just check it on that. Choose chat.
Should I read or first?
Yeah, 1 minute. I'm just checking it up. Yeah, you can take it.
Yeah,
if you can unshare the screen.
Yeah, I will unshare
the
it.
screen.
Yes, I will. Yeah.
So there are 8 questions. Should I read or you be taking one by one, sir?
I will take one by one.
Yeah.
Can we protect our equipment from source side harmonic if we install an isolation transformer at the incomer of the equipment? How effective it will be? I don't think isolation transformer gives a mitigation factor for an isolation transfer for the harmonics. Source side harmonic is predominantly a voltage harmonics. So I don't think isolation transformer will just, it is a 1:1 transformer which will actually transfer the same harmonics into the circuit. But only thing, the grounding part is different on the secondary side of the transformer. The second one is, can you explain 4x4? I will come back to you, Sachin, Sanjay. Just give me some time. I will take the other questions and then maybe I will go to the 4th slide and show it to you. There is not bothering line maintenance and higher authority pressing hard or bill recovery, only maintenance secondary. How can you guide in such a situation? First of all, monitoring, if there is proper monitor or if the industries provide data to the utilities, then there comes a necessity by the utilities to take necessary action. So naturally, everyone has lot of priorities, lot of work on the field. And how do we prioritize the power quality is a challenge among the humongous work pressures what we all have. So Haridas, I have to say that we need to collect data first, and then probably get a higher priority for these kind of problems to handle. So that's about that. And then Jagdish has asked, oh, I fell down. Harmonics compliance report. The most report shows only daily or weekly interval violations. Okay, you are talking about IEEE 519 or this thing. That's what I said. Most of them gives limits to the harmonics. That is how much of harmonics I can give, or I should not cross certain limits. That is what is harmonics. That is why it comes as weekly, because they are all statistical evaluation. 99 percentile, 95 percentile are all statistical evaluations. So it doesn't mean that if, for example, in IEEE 519, if you have 95 percentile, you have 952 times you need to comply within the standard or within the limits, and rest 50 times you can cross the limits. But asking them when it will happen doesn't give you any results, because you cannot control your load based on that, because your load works on the input of the material or the program what you have done on your loads. So in that sense, it becomes very difficult to do it. But limits are what is defined. But from the demand side, from the customers have to start going into the information of how they are crossing the limits, and then they should be able to take up much more study on the power quality parameters. Semiconductor industry asks for PQ meter from utility upfront prior to getting connected. How utility can provide this data? The semiconductor industry in India is growing rapidly. This is Sanjeev's question. It is the loss due to power quality in the semiconductor industry runs into billions of dollars. Data centers and semiconductor industries, because they make wafers, and in the process of wafer making, the supply reliability stands at most importance. So if that is, and that is why it is asking, and utilities should give those data, then only it will be helpful, because otherwise industry have to make themselves ready for these kind of situations. They should say, if according to the study of the utility, they give so much of good quality of power, they give so much of voltage fluctuations and voltage dips and sags in a month approximately. So in this situation, but unfortunately, it would be very difficult to be available in utility, because they also don't have power quality monitors in many of their feeders. Yeah, this is the fact of the day. So let's accept it.
Because utility has to put the meter, I think.
Utility has to put the meter and then show it to them.
They will be able to give this data.
Correct. Absolutely. And then Noel Pallavi says, just wanted to know, like, what are the signs that your system is suffering from harmonics? Measurement is the first thing which we start to doing it. But even a fuse blowing can be a harmonic problem. A failure of a neutral can also be a harmonic problem. So we need to analyze it. So somewhere we need to start monitoring. Monitoring becomes very, very important. Otherwise, there is no need for a IEC people to make a standard only for what to monitor, how to monitor. They know that we also don't know. That's why they have given what we all don't know in the form of IEC 63191. Yeah, that's the point.
So one of the signs can be overheating without no overload or no fault. So overheating can be one of the signs of harmonics.
Yes. Is there any institute giving training on this subject? 1 minute. Is there any? Sanjeev Kumar says, is there any institute giving training on the subject so that auditors can get training? We have to learn. There is no such training. Probably it could be a good topic to consider by some associations like NFE to give some institutions, probably, because as a part of continuous learning programs, I think Sachin is creating one kind of a program, if I understand correctly. So yes,
it is in the nascent stage, sir. We are trying to build a power quality trainings for that. Yes, sure.
Fantastic.
I think it would be good. We can build something in the NFE platform as well.
Yeah.
And then I have
Gopal's question.
Gopal, what is the scheme of connection of PQM? It is PQM connection is like your anything, you know, voltage connections are required, current connections are required, and then that's it. And an auxiliary supply is required for the any of the meters, like any MFMs, and rest are all done by them. So it's more important how you collect the data, how you get the data, and how you analyze it. That makes the difference. Is isolation transformer sufficient to avoid PLC malfunction? I would say yes and no. It depends on what kind of PLC malfunction has. Again, monitoring becomes important to do some kind of a monitoring and then take it up from there. Yeah. I recommend, Ravichandran says, I recommend to use mechanical UPS for semiconductor. As we know, the industry, well taken. Ravichandran sir, this is taken correctly. So I think we have answered most of the questions. Okay. I think I think with this, I have answered everything. Anything is missed out?
I think only that was a Sanjay sir. Can you explain phase 4
right.
again?
I will take on to the fourth phase. I will share my screen again and then go.
After this, if anybody wanted to ask questions, they can raise the hand and we can allow them to speak.
Yes, that is if live, if anybody want to talk, please raise your hand.
This is the phase 4. So when we do the phase 4, we design, when we start putting the meters, implementing the meters installation becomes the action, you know, before gridding, whether we have the CTs, whether we have the VTs connected in the system, or we need to buy something, those things also has to be taken as a part of the action plan. Yeah. So we need to see, because the meter will not alone work, it will predominantly work in conjunction with the CTs and VTs. It will also have the meters, how it needs to be connected into the system, what is the kind of say, for example, if the voltage voltage transformers in the system is add-on circuit or a 3-phase 2-wire measuring system, 3-watt meter measuring system, all those things needs to be considered and then documented as well, so that you know which feeder or which location, wherever you are putting, you have all the information in place, and then doing the commissioning of the devices as per the manufacturer's instructions. This is what it says. And you should ultimately create the documentation on the wiring, how the meter wiring is done, from which terminal you have taken CTs and VTs connections, and how the communication is designed for that particular meters. And then the documentation should also have what is the configuration put in the meters, what is the CT ratio, what is the VT ratio, what all various other memory configuration, if exist in the meter, how we are all doing it. All these things also to be documented on put in. That's what it says in this particular phase. Yeah.
So there is one live question. The G Sri Nivasalu. Can you speak? Hello. Yeah, please go ahead, Mr. G Sri Nivasalu.
Informative.
Yes.
My question is, actually we are working in some metro rail project. So in that we are having some dry type transformers, single source. From that source to, we have divided two sections. One is delta to star, another one is delta to delta. And from that we have studied the PQ. We have
We lost you.
Yes. We couldn't hear you after delta to star you were talking about.
Probably the internet connection of Mr. Srinivasan is not good.
Yeah.
I think he got disconnected.
Any other questions?
All the questions we have answered from question and answer section. If anybody want to talk, please raise your hand. Yeah, Rajesh, Mr. Rajesh. I think he has lowered hand. Yeah, Mr. Haridas. Please unmute yourself, sir.
Sir, one question is that. Hello, sir.
Yeah, go
Yes, I
ahead,
can
sir.
hear.
Sir, while system improvement lines, at some instant there was no new conductor available. So, can we use old conductor in place of new conductor? Is there any problem?
Not getting the question clear.
Yeah, question is not clear, sir. He was asking something about conductors.
While erection of line, LT lines or ST lines.
Yeah.
Erection of line.
Uh-huh.
Can we use old conductor instead of new conductor?
It depends on your project scope. To me, that's what it says. Because if your existing project says that you have to change the wiring, there has to be some reason for that. So if they would have asked for that reason. Only they are asking us to change with the newer line, and then it depends predominantly on the project proposal. So we will not be able to comment beyond that. It looks to me.
Is there any difference in current carrying capacity of old and new conductor?
But I think it's not related to our
Sir,
power
it's-
quality. I am not getting it.
Yeah. Please restrict to Please restrict your questions to today's topic.
Yes.
Okay.
Thank you, sir. I think all the questions are covered now. So I will take formally. I would before closing, I would like to once again thank Bala sir for this crisp presentation. I would also like to thank NFE for giving this platform and helping each and everyone to understand this new kind of topics on electric safety as well as power quality. So thank NFE and also thank the organizers to giving me this opportunity to moderate the session. So thank you all. Thanks all the participants who have enthusiastically attended this session as well as asked various questions, which help to understand, increase the understanding of everyone. So thank you all. Thank you, Hari sir.
Thank you. Thank you.
So formally we close the session.